Today we're going to be working on analyzing an ellipse, and we have two problems here with a given foci and major axis. So to start with, we're going to be graphing the given information, and that's the foci, which is at 0, 1, and 4, 1, and the major axis equal to 6. So just like what we did with our parabola, we need to sketch the given information in our graphing paper so we can easily visualize the parts that is given to us. Starting with the first foci at 0, 1, 0, 1. This is the first foci, and the other other focus will be at 4, 1, 1, 2, 3, 4, and this is the other focus. Now, with the given focus, we know that we can find the center, which is in between our two foci. So the center is somewhere here at 2 and 1. So now we're able to find the center of our ellipse, which is at 2 and 1. And in our formula, the center is h and k. Now, to summarize the formula that we're going to be using today, we know that the formula for the ellipse is given by this formula, where the a squared and the b squared will change according to how the ellipse is graphed. If we have a wide ellipse, our a will be bigger, and if we have a tall ellipse, our b value, which is with y, will be bigger. The center of our ellipse is at hk, represented by h and k in our formula. And to find the foci, we'll be using c squared is equal to a squared minus b squared. And also 2a is equal to the major axis. So these are the information or the formula that we're going to be using in analyzing our ellipse. Now, going back to our ellipse, since we have our center at hk, the next thing that we can find is the value of c in our variable. So notice that in our formula, we have a, b, h, and k. We know what h and k is in our standard formula. We just need to look for a and b. So to do that, we'll be using the other two formulas down here. And the next variable that we can find will be the value of c, which is the distance from the center to the focus, and there is 2 units in between the center and the focus, and that will be our c variable. And then the next thing that we can find will be the variable a using the formula 2a is equal to the major axis. So we have 2a equals the major axis, and we know that the given major axis is 6, so a is equal to 3. So now that we have our c and a, we can now find the variable b, which is needed in our standard form, by using the formula c squared equals a squared minus b squared. And by direct substitution, we know c is 2 and a is 3 minus b squared. And by solving for b squared, we'll be able to find the denominator in our equation. So we'll have b squared equals 3 squared minus 2 squared. And we'll have b squared equals 9 minus 4, which gives us 5. And if we take the square root of b, b would equal to square root of 5 is 2.23. And we're going to be using that value to find the vertex of our ellipse in a little while. So we have the value of b, which is 2.3 or 23, and b squared is equal to 5, and a squared is equal to 9. And we're going to use that in our formula or our standard equation of the ellipse. So to complete our work, x minus h squared all over a squared plus y minus k squared all over b squared is equal to 1 will be the formula that we're going to be writing. And we are replacing h, k with h and k, and the value of a squared and b squared by 9 and 5. So our equation will be x minus 2 squared all over, since the major axis is along the horizontal line, our a will be the bigger value, which is 9, plus y minus 1 squared all over 5 equals 1. And this is our standard equation of our ellipse. Now to complete our graph, since we already have the focus over here, let's just find the vertex by using the denominators of our equation. So since x has a denominator of 9, that means from the center going to the left and going to the right, we'll count 3 units because square root of 9 is 3. So we have 1, 2, 3. This is the first vertex, and the other vertex will be 1, 2, 3. 1, 2, 3 from the right. So that will be our vertex. And for the vertical vertex, we'll use the square root of 5, and the square root of 5 is 2.23. So from the center, we will count 2.23 units, 1, 2, and a little bit more somewhere here, and 1, 2 somewhere here. So if we're going to construct our guide given by we'll be able to draw our ellipse. And this is the graph of our ellipse given the standard equation of the ellipse in our work. Now let's answer problem number 2. So now we're going to be working on problem number 2, and in number 2 we're given the foci at 2, 0 and 2, 4. Major axis is at length 8. And by graphing, we'll be able to produce the foci and the center of the ellipse. So once again, this is the formula that we're going to be using. We need our h and k, a and b to construct our, or to generate our formula for the ellipse. So let's start with the first focus at 2, 0. So this is the first focus, and the other focus is at 2, 4. 1, 2, 1, 2, 3, 4. So the major axis is along the y-axis. So we'll find the center, which is in the middle of the 2 foci. So in between them, it will be at 2 and 2. So our center is at 2, 2. And the next variable that we can find will be the distance from the center to one of the foci, and that is 1, 2 units. So C is equal to 2. And the next formula that we're going to use is 2a is equal to the major axis to find the variable a. And using the formula, 2a equals 8, a is equal to 4. So now that we have our C and A, we'll be using C squared equals A squared minus B squared to find the other variable. So C squared equals A squared minus B squared, by using the formula, will be so b squared is equal to 12, and to find the value of b, which we're going to use in graphing in a little while, square root of 12 is going to give us 3.46. So now that we have all the variables that we need, we have C, A, and B, which is 3.46. Our A squared is equal to 16, and our B squared is equal to 12. Now, since this ellipse is a tall ellipse, we're going to switch our denominator. The denominator, which is 16, will go with y, and 12 will go with x. So in our formula, x minus h squared all over b squared plus y minus k squared all over a squared equal to 1 is the more appropriate formula to use, because your bigger denominator should go with the y-axis. So our formula will now be x minus 2 squared all over 12 plus y minus 2 squared all over 16 equal to 1. And this is our standard form. Now to complete our ellipse, since the major axis is along the y-axis, so our denominator for y, which is 16, square root of that is equal to 4. So you will count 4 units up, 1, 2, 3, 4, and 4 units down, 1, 2, 3, 4. So that is our vertical vertices, and the horizontal vertices will be with the square root of 12, which is 3.46. So from the center, you will move 1, 2, 3.46 to the right, and 1, 2, 3.46 to the left. And to draw our guide, our ellipse will be a tall ellipse. Since the major axis is along the y-axis. So this is how we analyze an ellipse given the foci and the major axis.